Welcome to the R Programming for Data Science course. In this course, we are going to cover the basics of R programming, data analysis, and machine learning. R is a powerful programming language for data analytics, and Google Colab an excellent platform for writing and executing R code. I'm going to add chapters to this video tutorial, and you can see them in the description of the video. I'm going to use Google Colab in the course. You can use other code editors like RStudio for executing R codes. Now we are in the Google Drive space. I'm going to use my right click and press on Google Collaboratory here for opening a new notebook. Here we have the Google Colab interface, and let's just close this drive, and you can access to this through your web browser without the need of any installation. It offers several advantages such as access to the computation resources and the ability to work on projects together with others. We now have a new notebook where we can write and execute our R code. The notebook consists of cells which can contain either code or text. To add a new cell, click on the plus button here, and like this you can add cells. Let's change the name of our file as new notebook, and we are going to change its extension here as .r. We are going to use like this. Now it's an R file. Now we need to make another change. We need to change the runtime because it comes as Python in the default version of the Google Colab. You are just going to press the change runtime type, and you are going to say R from here. And by saving, you are good to go. You can just connect from here, and we are all good to go for writing our codes into here. Now we are ready to go. Now let's write our first R code in the cell. Let's print hello R, and we are going to run this. You can do it by Shift plus Enter if you are using a Windows computer, and if you are using a MacBook, you can just use Command and Enter. So let's add cells for the other codes, and as you can see, the output hello R is displayed below the code cell. This is how we can run R code in Google Colab. Now you know how to write and execute R code in Google Collaboratory. R is widely used in the field of data analytics due to its extensive collection of packages and libraries. These packages provide a vast array of functions for data manipulation, statistical analysis, and machine learning. R also has a vibrant community of data scientists and researchers who contribute to its development. This means you can find plenty of resources, tutorials, and support online to help you along your data analytics journey. Additionally, R's versatility allows you to work with various data formats, including CSV, Excel, JSON, and databases. You can import and export data seamlessly, making it a valuable tool for real-world data analysis. Alright, that wraps up our introduction to R and Google Colab. Now we can keep with the basics of R programming. R uses a concise and expressive syntax that allows us to perform various operations efficiently. Let's start by exploring some basic data types in R. The most common data types in R include numeric, character, logical, and factors. To declare a variable, use the assignment operator or the equal sign. Here I'm going to create x as 5 with assignment operator and y as 4 with equal sign. Like this. I'm going to use the assignment operator for x and equal sign for y. And I'm just going to run the cell. And now we can check them by just writing their names. When we call x, 5 is going to be returned from now, and same is applied for y. Let's write x and run this, and let's write y and run this, and we can see the display. Now we are going to talk about operators. R provides a wide range of operators for performing arithmetic, logical, and relational operations. Let's explore some of these operators. Arithmetic operators include addition, subtraction, multiplication, division, and exponentation. Let's assign A as 10 and B as 3, and we are going to use our arithmetic operators now. Let's start by addition, and we are just going to write its name for seeing the result. Alright, let's keep with subtraction. I also increased the font size for you to see better, and now we are going to keep with multiplication here. We are going to say a multiplied by b, and we are going to print this like this. And now we are going to do division. Division, we are going to use this symbol and we are going to say division here. And it's time for exponential. It's going to be equal to the, you don't need space and you can just write its name again. And we are just going to run this. Great, we have performed various arithmetic operations using the variables a and b. Now let's move on to the basic data structures in R. R provides powerful data structures like vectors, matrices, and arrays. Let's start with vectors, which are one-dimensional arrays. For creating a vector, we are going to say my vector. We need to use C for creating vectors, and let's say 1, 2, 3, and 4. And let's see what does it look like. We have created a vector, my vector, containing the values 1, 2, 3, and 4. We can access individual elements of the vector using indexing. For this, we are going to say my vector, and we are going to use 2 like this for reaching to the second index, and when we run the cell, we can see that we got the 2. If you change this to 3, you are going to see the 3, it's the index number. We just accessed to the second element of our vector. Now let's move on to matrices, which are two-dimensional data structures. To create a matrix, we use the matrix function. Let's create a 3-3 matrix called my matrix. For creating a 3 times 3 matrix, we are going to say my matrix is going to be equal to the matrix function 1 to 9. Number of rows is going to be equal to 3 and number of columns is going to be equal to 3. And let's see what does it look like by running this cell. We have created a 3 times 3 matrix, my matrix with values 1 to 9. We can access individual elements of the matrix using row and column indices. For example, let's say my matrix 2 and 3 here. Now with this code we are accessing the element in the second row and third column. By running this we are going to see that. Now we are going to explore arrays, which are multidimensional data structures. We can create arrays using the array function. For creating an array, we are going to say my array, and we are going to say array 1 to 12, and the dimension here is going to be equal to the vector with, let's say 2, 2, and 3. Let's see its shape. We have created array my array with the values 1 to 12. We can access elements of the array using indices for each dimension. For this, we are going to say my array, and let's say 1, 2, 3, and let's run this. And we reached to the 11 here. We reached to the element in the first row, second column, and the third depth. That wraps up our explanation of R basics. In this module, we covered R syntax, data types, variables, operators, and basic data structures like vectors, matrices, and arrays. Now we are going to talk about data manipulation and cleaning techniques using R. We will start by downloading an existing dataset in R. For this demonstration, we will use the mtcars dataset, which comes preloaded in R. This dataset contains information about various car models and their performance metrics. To import the mtcars dataset, we can simply access it using the dataset name. Let's load the data and display the first few rows using the head function. Let's load it by data, and we are going to write mtcars here, and when we run this, we have the mtcars. And head function is a really useful function that lets you have an insight about the dataset, and you're going to use this every time when you're working with new data. And let's run this and see how our data looks. Great, we can see the first 6 rows of the mtcars dataset. It includes information about car models such as miles per gallon, number of cylinders, horsepower, and more. Before we proceed with data manipulation, let's talk about data preprocessing. One crucial step is handling missing values. Let's check if there are any missing values in the mtcars dataset. For this, we are going to say sum is NA, which is going to check if there is any NA values in the dataset, and we are just going to pass the empty cars here, and when we run this, we can see that the empty cars dataset doesn't contain any missing values. Another important aspect of data processing is data transformation. Let's apply a common transformation, logarithm transformation, to the horsepower column. We are using $sign in R for reaching to an existing column or creating a new one. So what we are going to do is we are going to say empty cars and we are going to create a new column. So we need the $sign here, and we are going to say horsepower.logarithmic is going to be equal to logarithm empty cars, and we need the $sign again, and we are going to say I can find $sign, okay, horsepower, and we are going to say head empty cars, and in this way we can see the new column we have at the end. We have added a new column HP logarithmic to the dataset containing the logarithm transformed values of horsepower. Now let's move on to the data manipulation using a popular package in R. The dplyr package provides easy to use functions for filtering, selecting, arranging, and summarizing data. I'm going to scroll down a little bit, and let's say we want to select specific columns from empty cars dataset such as MPG, CYL, HP, and GR. For this we can do, for installing a library in R, you're just going to say library, and you're going to pass the library's name inside of it. We are going to use with dplyr. So I'm just going to run like this, and when it's installed we are good to go with our operations. We are going to say selected columns is going to be equal to the select empty cars, MPG, CYL, 8 horsepower, and GR, and let's use the head method for seeing the selected columns. And when we run this, we can see that the columns we selected, we have created a new dataset with only the selected columns. The importing library part is important here, because if you don't do this, the select method and the others that we are going to do won't work in your system or computer on your running environment. We can all say that. Now let's filter the empty cars dataset to include only the cars with more than 200 horsepower. For this we are going to create something like high horsepower cars, and this is going to be equal to the filter. We are going to use the filter method. We need to pass the dataset name in, and we are going to say horsepower is greater than 200, and let's see the head of it, and we can have an idea about what we have. In this way we have filtered the dataset and kept only the cars with more than 200 horsepower. Now let's arrange the empty cars dataset in descending order based on miles per gallon value. For this, the thing we are going to do is we are going to create something like arranged cars, and we are going to say arrange empty cars. You can see that R has a really easy syntax, like you are just like using English here. Descending order, and you are going to pass the miles per gallon, and we are going to use the head method again for arranged cars, and we are going to see the output that is in the descending order for the MPG values. We have arranged the dataset based on it. Let's summarize the empty cars dataset by finding the average horsepower and maximum miles per gallon. For this we are going to say, let's scroll down a little bit, we are going to say summary data is going to be equal to the summarize empty cars, and average horsepower is going to be equal to the mean method here we are going to use, and maximum MPG is going to be equal to the maximum. We are going to use function like this again, and we are going to say MPG. Let's use head summary data, and when we run this we are going to see our result. Actually there is no need of head here, also we can just delete it and we are going to see the same output. Great, we have obtained the average horsepower and maximum miles per gallon here. Now let's move on to data cleaning techniques. One common task is removing duplicates from the dataset. Let's check if there are any duplicate rows in the empty cars dataset. For this we are going to say duplicate rows is going to be equal to the empty cars duplicated. No, we need something else here. Duplicated. And we also need to change this when we are writing code. And we are going to say empty cars here. And we are going to do this. And when we run this like this, we can see if we have any duplicates. If you have duplicated rows, then they are going to be displayed in here. And as we can see, we don't have any duplicate rows in the empty cars dataset. Also, if duplicates were present, we could remove them using distinct function. Another important task is handling outliers. Let's identify potential outliers in the MPG column using a box plot. For this, we are going to say box plot and empty cars. Also, we are going to say MPG. Main is going to be, it's the title. We are going to say box plot of MPG. And let's see the output here. By analyzing the box plot, we can identify any observations that fall significantly outside the whiskers as potential outliers. That wraps up our exploration of data manipulation and cleaning techniques using R. In this module, we covered downloading an existing dataset, data preprocessing techniques such as handling missing values and data transformation, data manipulation using the dpval-ir package, and data cleaning techniques like removing duplicates and identifying outliers. Now we will talk about exploratory data analysis using R. We will start by examining data using descriptive statistics, followed by data visualization using the ggplot2 package. Then we will dive into statistical summaries and visualizations by variables. Finally, we will explore correlation analysis and identify relationships within our data. Descriptive statistics provide a summary of the main characteristics of the dataset. Let's start by examining the summary statistics of the empty cars dataset. For this, we are going to say summary empty cars, and we are going to run this. And we can see the summary statistics here. The summary statistics give us an overview of key metrics like minimum, maximum, median, and quartiles for each variable in the empty cars dataset. We can also calculate additional descriptive statistics such as mean, standard deviation, and correlation coefficients. Let's calculate the mean and standard deviation of the MPG column. For this, let's start by mean. We are going to say mean MPG is going to be equal to the mean empty cars, and we are going to use $sign for reaching to the columns, remember it, and we are going to say MPG, and let's see how does it look. And now let's talk about the standard deviation. For this, we are going to say standard deviation MPG. We are going to use S and D together for standard deviation empty cars and $sign again for reaching to the column, and we are going to say standard deviation MPG. When we run this, we can see the standard deviation value here. Great, we have calculated the mean and standard deviation of the MPG column. Now we are going to talk about hypothesis testing. Hypothesis testing is a fundamental concept in statistical analysis. It allows us to test a claim or hypothesis about a population based on sample data. The p-value represents the probability of obtaining result as extreme as the observed data, assuming the null hypothesis is true. Let's perform a hypothesis test to determine if the average miles per gallon is significantly different from 20. We are going to use one sample t-test for this. We are going to say t-test result, and how we are going to do is, let's use assignment operator this time. We're going to use t-test and empty cars and $sign for reaching the MPG, and mu is going to be 20, and t-test result. And we are waiting for our answer, and we can see our p-value here, which we are going to give our decision based on this. The t-test provides us with the test statistic, degrees of freedom, and the p-value. R provides various statistical tests to analyze different types of data. Let's explore a few common tests, starting with the chi-square test. Suppose we want to determine if there is an association between the number of cylinders and the transmission type. Let's perform a chi-square test for independence. For this, we are going to say chi-squared test is, and it's going to be equal to the chi-square dot test empty cars. We are going to use the dollar sign for reaching to the column CYL, and we are going to say empty cars am here, and we are going to say chi-square test, and we are going to run this like this. The chi-square test assesses the association between the number of cylinders and transmission type, and provides us with the chi-square statistic, degrees of freedom, and p-value. Now we are going to talk about ANOVA. Analysis of variance, in other terms, is a statistical technique used to compare means across multiple call groups. Regression analysis, on the other hand, helps us understand the relationship between dependent and independent variables. We are going to talk about these two now. Let's start with ANOVA to compare the average miles per gallon among cars with different numbers of cylinders. We are going to do one-way ANOVA for this. We are going to say ANOVA result is going to be equal to the MPG CYL. Data is going to be empty cars, and we are going to say summary ANOVA result, and we are going to run this like this. The one-way ANOVA compares the means of MPG across different numbers of cylinders and provides us with the F statistic, degrees of freedom, and p-value. Let's perform a linear regression analysis to predict the miles per gallon based on horsepower. For this, we are going to say linear regression model is going to be, let me fix this quickly, is going to be equal to the LM, which represent linear model, MPG, and horsepower. Data is going to be empty cars, and let's get a summary of this linear model. The linear regression model helps us understand the relationship between miles per gallon and horsepower, providing us with the regression coefficients, standard errors, t-values, and p-values. That concludes our exploration of statistical analysis in R. In this module, we covered an introduction to statistical analysis, hypothesis testing, and p-values. Common statistical tests like t-tests and chi-square tests, and ANOVA and regression analysis. Now we are going to talk about machine learning in R. Machine learning involves developing models that can automatically learn patterns and make predictions or decisions based on data. Let's import the library rpath, and we are going to start to create creation of our machine learning models now. We have loaded the required package for machine learning in R. If we require another, we can just download them on that models site. Now let's talk about machine learning algorithms. Supervised learning algorithms learn from labeled data to make predictions or classify new instances. Let's explore a few common supervised learning algorithms using the empty cars dataset. Let's begin with linear regression, which is used for predicting continuous variable based on one or more independent variables. You know that we already did a linear model. We are going to do the same thing. We are going to say LM linear model, and it's going to be equal to the linear model MPG, and let's include all. Data is going to be empty cars, and we are going to get the summary of this model like this. You can see that we covered all of the columns in the X side, and you can see the p-values, t-values, standard errors here, and the coefficients. And you can see also residuals and that kind of statistical summaries like that. Since this is a R course, I'm not talking about any statistics or outputs. You can visit my statistics course on Udemy for covering this kind of topics if you are interested into this. The linear regression model helps us predict the miles per gallon based on other variables in the empty cars dataset. Now let's explore logistic regression, which is used for binary classification problems. For this, we are going to say logit model is going to be equal to the GLM vs. Data is going to be equal to the empty cars, and family is going to be equal to the binomial. And we are going to get the summary of this model like this. By the way, I just said I'm not going to talk about any statistics, I'm just going to show the techniques. But these p-values are terrible. You generally want something less than 0.05, and both of the models are not good, we can say that, but you can just reduce the column size, like you can just take 3 of this and train a better model. It's just a hint for you. These p-values are terrible, I just can't say that. In this course we are just learning how to create these models, like their syntax, not the idea behind them. Okay, we can move on now. The logistic regression model helps us classify the vehicle types based on the other variables in the empty cars dataset. Now let's talk about unsupervised learning algorithms. Unsupervised learning algorithms are used when we have unlabeled data and want to discover patterns or group similar instances together. Let's explore clustering as an example of unsupervised learning. We are just going to cover clustering in this course. We will use the k-means algorithm to cluster the vehicles based on their features. We are going to say k-means model is going to be equal to the k-means, and we are going to say empty cars. We are going to open this and we are going to create a vector like mpg and horsepower, and we are going to say here centers is going to be equal to 3, and let's get cluster here. We are going to say k-means model and we are going to use cluster here, and we are going to run this cell. Now the k-means algorithm helps us cluster the vehicles into different groups based on their miles per gallon and horsepower. That was all for our programming for data science course. Thanks for watching. Thanks for listening to me. If you liked the video, you can subscribe to my channel for seeing more content like this. Have a great day.